Start.
So good afternoon sir, good afternoon students. So fifth chapter, magnetism and matter. So first, magnetism. So already you know about what is meant by magnetism. So magnetism means the property of material which attracts bits of iron and steel is called magnetism. So ಇದು ಒಂದು ಪ್ರಾಪರ್ಟಿ. ಸೊ ಯಾವ ಒಂದು ಮಟೀರಿಯಲ್ಲು ಐರನ್ ಅಥವಾ ಸ್ಟೀಲನ್ನು ಅಟ್ರ್ಯಾಕ್ಟ್ ಮಾಡ್ಕೊತ ಒಂದು ಪ್ರಾಪರ್ಟಿ ನಾವೇನಂತ ಕರಿತೀವಿ, ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಂತ ಕರಿತೀವಿ. ಒನ್ಸ್ ಅಗೇನ್, ವಾಟ್ ಈಸ್ ಮೆಂಟ್ ಬೈ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಮೀನ್ಸ್ ದ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಮಟೀರಿಯಲ್ ವಿಚ್ ಅಟ್ರ್ಯಾಕ್ಟ್ಸ್ ಬಿಟ್ಸ್ ಆಫ್ ಐರನ್ ಆ್ಯಂಡ್ ಸ್ಟೀಲ್ ಈಸ್ ಕಾಲ್ಡ್ ಮ್ಯಾಗ್ನೆಟಿಸಮ್. ದ ಪ್ರಾಪರ್ಟಿ of material which attracts bits of iron and steel is called magnetism. So next, magnetic material. So the property of material which possesses magnetism property, so that material is called what? Magnetic material. ಅಂದರೆ ಯಾವ ಮಟೀರಿಯಲ್ಗಳು ಮ್ಯಾಗ್ನೆಟೈಸಮ್ ಪ್ರಾಪರ್ಟಿಯನ್ನು ತೋರಿಸುತ್ತೋ ಅಂತಹ ಮಟೀರಿಯಲ್ಗಳು ನಾವೇನಂತ ಕರಿತೀವಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮಟೀರಿಯಲ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಒನ್ಸ್ ಅಗೇನ್, ಸೊ ದ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಮಟೀರಿಯಲ್ which possesses magnetism property, that material is called what? Magnetic material. So next one, bar magnet. So this is a bar magnet. So this is the north pole and this one is the south pole. What is meant by bar magnet means it is an artificial rectangular shaped magnet which possesses two poles, stands north and south pole at the ends. That is called ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್. ಈ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟನ್ನು ನಾವು ಸರ್ವೇ ಸಾಮಾನ್ಯವಾಗಿ ಹಳ್ಳಿಗಳಲ್ಲಿ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂತಂದರೆ, ನಾವು ಈ ಚೌಕ ಬಾರ ಅಂತ ಏನು ಕರಿತೇವಲ್ಲ ಆ ಒಂದು ಆಟದಲ್ಲಿ ಈ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟನ್ನು ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ಈ ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಶೇಪ್ ಇರ್ತಕ್ಕಂಥ ಐರನ್ಲಿಂದ ಮಾಡಿರ್ತಕ್ಕಂಥ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟನ್ನು ನಾವು ಆ ಒಂದು ಗೇಮ್ಗೆ ಏನು ಮಾಡ್ತೀವಿ, ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಒಟ್ಟಾರೆಯಾಗಿ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅಂದರೆ ಇಟ್ ಈಸ್ ಆ್ಯನ್ artificial rectangular shaped magnet which possesses two pole stands north and south pole at the ends is called what? Bar magnet. So next one, magnetic dipole. So in the previous chapter, means in the first chapter electric dipole, electric flux, electric dipole ಅಂತನ ನೀವು ಸ್ಟಡಿ ಮಾಡಿದ್ದೀರಿ. ಅದೇ ರೀತಿಯಾಗಿ ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್. ಸೊ ಅಲ್ಲೇನಂತ ಹೇಳಿದ್ರೆ ನೀವು ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಅಂತಂದರೆ ಇಟ್ ಈಸ್ ಅ ಸಿಸ್ಟಮ್ ಆಫ್ ಟು ಈಕ್ವಲ್ ಆ್ಯಂಡ್ ಅಪೋಸಿಟ್ ಪಾಯಿಂಟ್ ಚಾರ್ಜಸ್ ಸಪ್ರೇಟೆಡ್ ಬೈ ಎ ಸ್ಮಾಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಕಾಲ್ಡ್ ವಾಟ್? ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಅಂದರೆ. ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್ ಅಂತಂದರೆ it is a system of two equal pole strength of a pole of the magnet and separated by a small distance. So that is 2L. So that is called magnetic dipole. And next one is magnetic dipole moment. Magnetic dipole moment, and it is denoted by MB. So electric dipole moment ಅಂದರೆ it is the product of either charge and the separation of the distance is called electric dipole moment, and electric dipole moment is denoted by P. So P is equal to Q into 2a. It is a product of either charge and the separation of the distance is called electric dipole moment. Here the magnetic dipole moment, ಇಲ್ಲಿ ಚಾರ್ಜ್ ತಗೊಂತೀವಿ ಬಟ್ ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕಲ್ಲಿ ಪೋಲ್ ಸ್ಟ್ರೆಂತ್ ಅನ್ನು ತಗೊಂತಾ ಇದೀವಿ. ಹಾಗಾದರೆ ಸೊ ಏನಂತ ಹೇಳ್ತೀರಾ, ದ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ pole strength of either pole of the magnet and the separation of the distance is called what? Magnetic dipole moment. So magnetic dipole moment mb is equal to qm into 2l. Sir q ಅಂದ್ರೆ ಚಾರ್ಜ್ ಏನು ಸರ್ ಅಲ್ಲ, qm ಅಂತ ಬರ್ದಿ ನೋಡ್ರಿ. ಇಟ್ ಇಸ್ ಅ ಪೋಲ್ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟ್. ಸೊ qm into 2l. ಇದು ನಿಮ್ಮ ಡಿರೈವ್ಗೆ ನೆಕ್ಸ್ಟ್ ಈ ಈಕ್ವೇಷನ್ ತುಂಬಾ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಸೊ ದೀಸ್ ಆರ್ ದ ಬೇಸಿಕ್ ಡೆಫಿನಿಷನ್ಸ್ ಫಾರ್ ದಿ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಆ್ಯಂಡ್ ಮ್ಯಾಟರ್. ಒನ್ಸ್ ಅಗೇನ್, ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಂದರೆ ದ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಮಟೀರಿಯಲ್ which attracts bits of iron and steel is called magnetism. So magnetic material ಅಂತಂದರೆ the property of material which possesses magnetism property, so that is called magnetic material. So what is meant by bar magnet? It is a rectangular artificial shaped bar magnet which possesses two pole strands, north and south pole. At the ends is called what? Bar magnet. Magnetic dipole. So the system of two equal pole strength of the pole of the magnet separated by a small distance is called what? Magnetic dipole. The last one is magnetic dipole moment. So it is a product of pole strength of the either pole of the magnet and the separation of the distance is called what? Magnetic dipole moment. So these are the basic definitions for the magnetism and matter. So next one is magnetic flux and magnetic field lines. So magnetic flux. So already electric flux ಅನ್ನು ಕಲಿತಿದ್ದಾರೆ, ಇಲ್ಲಿ magnetic flux. So magnetic flux is denoted by phi. So the total number of magnetic field lines passing through that surface area is called what? Magnetic flux. Electric flux ಅಂದ್ರೆ ಏನಂತ ಹೇಳ್ತಾ ಇದ್ದೀರಿ? So again it is denoted by phi is equal to E into ds. So the total number of electric field lines passing through that surface area is called what? Electric flux. But here the magnetic flux, so magnetic flux is defined as the total number of magnetic field lines passing through that surface area is called what? Magnetic flux. And one more important concept is magnetic field lines. Magnetic field lines. So the imaginary loop around a magnet, so involving both north and south pole, for which so at a given point it represents the direction of the magnetic field is called what? Magnetic field lines. So what are the important properties of the magnetic field lines? Already in the first chapter electric field lines, and what are the important properties of electric field lines you can study. But here properties of magnetic field lines. Again, first property, magnetic field lines of a magnet or solenoid forms a continuous closed loop. ನೋಡ್ರಿ ಏನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ, magnetic field lines of a magnet or solenoid forms a continuous closed loop. So this is the first property. Second property, magnetic field lines cannot intersect with each other. ಸೊ ಯಾವುದೇ ರೀತಿಯಾಗಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಏನಾಗಲಿ ಒಂದಕ್ಕೊಂದು ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗೋದಿಲ್ಲ. ಆ್ಯಂಡ್ ದ ಥರ್ಡ್ ಪ್ರಾಪರ್ಟಿ, ದ ಟ್ಯಾಂಜೆಂಟ್ ಟು ದ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ at the given point it represents the direction of the magnetic field at that point. So these are the properties of the magnetic field lines. ನಾಳೆ ನಿಮ್ಗೆ ಕೇಳ್ಬೋದು define magnetic field lines and write the properties of magnetic field lines ಅಂತಂದರೆ ಸೊ ನೀವು ಏನು ಬರೀತೀರಾ ಹಾಗಾದರೆ, so it is an imaginary loop around a magnet involving both north and south pole, for which so it represents the direction of the magnetic field. So what are the properties of the magnetic field lines? First property, magnetic field lines of a magnet forms continuous closed loop, and second property, magnetic field lines cannot intersect with each other, and third property, tangent to the field lines at a given point it represents the direction of the magnetic field. So these are the properties of the magnetic field lines. Next one, very important derive is magnetic field due to magnetic dipole at a point on the axial line. So magnetic field due to magnetic dipole at a point on the axial line. So it's very important for your examination point of view. Derive an expression for magnetic field due to magnetic dipole at a point on the axial line. Suppose this is a bar magnet. Okay, this is the axial line. So this is B1, so this is B2, this point is called P point. So this is the north pole and this one is the south pole. So each pole of the magnet is QM and this is also QM. So this is a center point O. So here to here distance is L and here to here distance is L. Totally L plus L, so it is 2L. So the center of the point O2 at point P distance is, that is small r. So a bar magnet is a line. So this is a bar magnet is a line passing through the two poles, north pole and south pole. Let P be a point at distance r from the center O. If QM is the pole strength of the each pole of the magnet and 2L is the distance between the two poles is as shown in the figure. So now we consider magnetic field B1 at point P. Magnetic field B1 at point P due to the north pole. Is given by. So ನೀವು ಆಲ್ರೆಡಿ ಫಸ್ಟ್ ಚಾಪ್ಟ್ರಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಎಟ್ ಎ ಪಾಯಿಂಟ್ ಆನ್ ದ ಆಕ್ಸಿಯಲ್ ಲೈನ್ ತಗೊಂಡಿದ್ರಿ ಸೇಮ್, ಬಟ್ ಅಲ್ಲೇನು E1 E2 ಅಂತ ಬರ್ತಾ ಇತ್ತು ಆ್ಯಂಡ್ ಚಾರ್ಜಸ್ ಬರ್ತಾಯಿತ್ತು, ಇಲ್ಲಿ ಪೋಲ್ ಸ್ಟ್ರೆಂತ್ ಬಂದಿದೆ. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ E1 at point P ಡ್ಯೂ ಟು ದ ಚಾರ್ಜ್ ಪ್ಲಸ್ Q, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ E2 at point P ಡ್ಯೂ ಟು ದ ಚಾರ್ಜ್ ಮೈನಸ್ Q ಅಂತ ತಗೊತಾ ಇದ್ವಿ. ಬಟ್ ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ B1 at point P, ಸೊ ಡ್ಯೂ ಟು ದ ನಾರ್ತ್ ಪೋಲ್ ಈಸ್ ಗಿವನ್ ಬೈ, ಸೊ ವಿ ಕ್ಯಾನ್ ರೈಟ್ B1 is equal to mu naught divided by 4 pi into. ಸೊ ಪೋಲ್ ಸ್ಟ್ರೆಂತ್ ಏನು ಚಾರ್ಜ್ ಇಲ್ಲಿ ನಮ್ಮದು ಚಾರ್ಜ್ ಬದಲಾಗಿ ಪೋಲ್ ಸ್ಟ್ರೆಂತ್ ಇದೆ QM divided by R minus L whole square. So this is equation number 1 in bracket. Away from the north pole. So similarly magnetic field B2 at point P, so due to the north pole ಬದಲಿಗೆ ಯಾವ್ದು ತಗೋಬೇಕು ನಾನು south pole, due to the south pole is given by. So therefore B2 is equal to mu naught divided by 4 pi into again QM divided by R plus L whole square. So this is equation number 2 in bracket. So ಯಾವ ಕಡೆ ಹೋಗ್ತಾ ಇದೆ ನೋಡಿ, towards the south pole, towards the south pole. So now the resultant magnetic field, the resultant magnetic field, the resultant magnetic field. So we can write B is equal to B1 minus B2, equation number 3. ನೋಡ್ರಿ, magnetic field B1 at point P due to the north pole ಇದನ್ನು ತಗೊಂಡೆ. So mu naught by 4 pi qm, so r minus l whole square, because ಯಾಕಂತಂದರೆ it is pass ಆಗ್ತಾ ಇದೆ away from the north pole, therefore r minus l. So magnetic field B2 at point P due to the south pole is given by B2 is equal to mu naught by 4 pi again qm divided by r plus l ಅನ್ನು ತಗೊಂತಾನೆ, because towards the south pole. ನಿಮಗೆ ಕಿರ್ಚಾಫ್ ಲಾಸ್ ಅಲ್ಲಿ ನಾನು towards the junction, away from the junction ಹೇಳಿದೆ. towards the junction ಅಂದರೆ it can take positive, away from the junction it can take negative. ಸೊ ಅದೇ ರೀತಿ ಇಲ್ಲಿ r minus l, r plus l. So substitute equation 1 and 2 in equation 3. So put equation 1 and 2 in equation 3. So put ಮಾಡಿದ್ರೆ ಏನಾಯ್ತು ಹಾಗಾದರೆ, so B is equal to mu naught divided by 4 pi into qm divided by r minus l whole square minus again mu naught by 4 pi into qm divided by r plus l whole square. So what is the common thing here? Mu naught by 4 pi into qm, mu naught by 4 pi into qm. So this is a common thing, so it can take outside. Then what is the remaining term? So therefore we can write so ಏನಾಯ್ತು ಹಾಗಾದರೆ, B is equal to mu naught by 4 pi into qm ಅನ್ನು ಹೊರಗಡೆ ತೆಗೆದೆ. ಸೊ 1 divided by r minus l whole square minus 1 divided by r plus l whole square. So now take LCM. So B is equal to mu naught divided by 4 pi into qm as it is. So this is a minus b, a plus b, a minus b into a plus b. So we can write a square minus b square. So therefore we can write r square minus l square. Mele whole square is, you can write directly, you can write whole square. So then r plus l whole square minus r minus l whole square. So next you can simplify it. So B is equal to mu naught divided by 4 pi into qm into bracket of a plus b whole square expand. So r square plus l square plus 2rl minus a minus b whole square, a square plus b square minus 2ab. So here minus sign, so it can multiply it. So therefore directly we can write r square minus l square plus 2rl whole divided by r square minus l square whole square. So r square and minus r square get cancelled, plus l square minus l square get cancelled. So then, so next B is equal to mu naught divided by 4 pi into qm. So into bracket of 2rl plus 2rl, can write 4rl divided by r square minus l square whole square. So next ಈ 4rl ಅನ್ನು ನಾನು ಈ ಥರ ಬರ್ಕೋಬೋದಾ? ಸೊ B is equal to mu naught by 4 pi into qm into 2l into 2r divided by r square minus l square whole square. ಸರ್ ಯಾಕೆ ಸರ್ 2l into 2r ಅಂತ ಬರೋದು? 2 2s are 4, l into r rl ಮತ್ತು ಸೇಮ್ ಅದೇ ಬಂತು, ಈ ಥರ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಬರೆದೆ. ಯಾಕೆ ಸರ್ ಹಿಂಗೆ ಬರೆದ್ರಿ ಅಂತಂದರೆ, ಸೊ qm into 2l, the product of pole strength of the pole of the magnet and the separation of the distance is called what? Magnetic dipole moment. So therefore we can write B is equal to mu naught divided by 4 pi into qm into 2l ಅಂದ್ರೆ ಏನಂತ ಬರ್ತೀನಿ mb, then 2r ಇದೆ 2mbr divided by r square minus l square whole square. From this figure, for a short magnet, so for a short magnet, so r is much greater than l, then l square can be neglected. L square can be neglected. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನಂತ ಬರಿಬೋದಾಗಾದರೆ ಎಲ್ ಸ್ಕ್ವೇರ್ ಆರ್ ಎಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಆರ್ಗಿಂತ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಆರ್ ಈಸ್ ಮಚ್ ಗ್ರೇಟರ್ ದೆನ್ ಎಲ್ ಆಗಿರೋದ್ರಿಂದ ಎಲ್ ಸ್ಕ್ವೇರ್ ಏನಾಗ್ತಾ ಇದೆ ಇಲ್ಲಿ ನೆಗ್ಲೆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಏನು ಉಳಿತು ಹಾಗಾದರೆ ಓನ್ಲಿ ಬಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ಮ್ಯೂ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ 4 ಪೈ ಇಂಟು 2mbr divided by r square whole square ಉಳಿತು. L square neglect ಆಯಿತು. Then B is equal to mu naught divided by 4 pi into 2mb into r divided by r to the power of 4 ಆಯಿತು. 2 2s are 4 ಆಯಿತು. 1 r and 1 r get cancelled. Then finally B is equal to mu naught divided by 4 pi into 2mb divided by r cube. So this is derive an expression for magnetic field due to magnetic dipole at a point on the axial line. Thank you. Next class continue ಮಾಡ್ತೀನಿ.